now. So we are recording as usual. You know, anyone that doesn't want to be named in the recording or there, you're not going to be on voice generally. But if you do, you'll be recorded. And if you don't want us to mention your name, just let us know. Other than that, we will keep saying like, right, Amrit asked this, or Simran asked that, or Adam says this, or whatever. So just bear that in mind. The recordings do go sort of up to YouTube unlisted and linked through here. So. Right. First thing I want to do is I wanted to go through. Let me get my notes so I don't have to keep paging backwards and forwards to stuff. Is to show you how to push your repository back to your remote. Okay, so I'm working on an animated video at the moment that puts together sort of a lot of the concepts about Git, so that you get more used to the concepts, of pushing things, checking things in. So if you hear me say words like remote, they'll get explained a little bit more. If you're not sure already, then you can always ask. So sometimes we use words without really realizing that they might seem alien the first time you get used to it. Right, so I'm going to share my screen. I'm going to try and share my screen. There we go. Get back into the VM. No, that was turning my camera off. This is going well today. There we go. Okay, so hopefully everyone can see my VM.
Yep.
Brilliant. So we should have, first of all, we've made a fork of our repository. So I'm going to go through this again, even though it's something that we did previously. I'm going to go through it again just so that you can sort of see where we are with all of these different bits and pieces. So github.contra.ac.uk, and if you can click on the links to go through, but I think I can remember where we were. Transcoder. So from here, you'd be making a fork. So far, we've got sort of 58 people have made forks. I think the others probably just did a clone or download. So if you've just done a clone or download, don't try to push back. You won't have the credentials for it. You'll need to fork it and put your code into that new fork, as you'll see in a minute.
Can you zoom in for him, James?
Please. I can possibly zoom in.
I believe in you.
It's not, there we go.
Yay.
So I can zoom in. There's fork. So I'm going to click on it. It says I've actually already done this. I could do it again and put it somewhere else, but I'm just going to click on this one. If it's the first time you do it, it'll try and make it as your username /transcoder. So this is my username. You can see usually it's not my username that goes in. It's CEH. So that's the ethical hacking group. So when you clone it, it goes to you, and here it is. So there is my repository. You can see it's in exactly the position that it's currently in on the website. We go to clone or download. If it's on HTTPS, that's fine. If it's not, you should be clicking use HTTPS. Here it says use SSH. If you know how to set up SSH keys, you can do that. That's absolutely fine. And I'm going to make a video a little bit later on how to do that, because I think it's a better way to work. It just takes a few more steps of setup. But for now, clone with HTTPS is fine. We copy this, which you can do by selecting it or clicking this. And then we're going to clone it. So I'm going to go into a temporary directory and already have that there. Git clone.
Pretend you didn't just teach them all to do RMRF.
Yes, well, it's useful. So delete recursively force. It's not something to play about with if you're not sure what you're doing, because it will delete everything that it can and won't ask you to confirm. But there we go. So git clone, and then the thing that I just copied. So I'm in a temporary directory because I don't want to confuse this with the original copy that I've got. But there we go, and you can see it clones the repository, puts the stuff in place. Possibly it will ask you for your credentials if you change your repository private, but by default it will be public, the same as the original. So I'm going to go in. So I'm going to Transcoder. Here's my stuff. I can do all my tests. I can make the virtual environment, do whatever I need to do, and I can type git status to see where we are. Okay, so we talked a little bit about status and check-ins, and you can go through the documentation we've already put up for that. But let's say that I've made a change, so I'm going to use Nano to edit README for now. Okay, so it's the same as if you edit your source code files. And what you should do, one of the things you should do is put your name here, right? So this is left. So this is me and me. And if I type git status, you can see that I've got a modified thing. Okay, so you can see readme.md is modified. Good. So now I want to git add readme, and what this does is it says this is now a staged change. This is one of the things that I want you to change. If I change multiple files, so let's say I've also changed a transcoder file. Let's say I've made some really important changes. Go fix that typo. Save that and exit. Status tells me I've got one thing that is to be committed and one thing that is not currently staged. It even tells me what I need to do that. So git add, and I'm going to add source transcoder.py because that's the other thing that I want added in. And now git status will tell me there are two things. You can notice as well that Z shell, the way it's set up, if you're using the given VM, is giving me lots of information visually while I'm here. So when I first came in, it shows me this little icon, which tells me I'm in a Git repository, and this green bit here tells me which branch I'm on. We're not using branches particularly yet. I will give you some more info later. If we don't use them ever, then I'll put it in there at the end of the module, so you've got it as a reference. If we use it along the way, and I don't think we will really, maybe when we get to the group work towards the end, we'll talk about it then. But essentially, it's the name of the current version I'm working on, and for the most part, we're just going to work on master, so it won't change. So you can see little icon looks like some branches, you know, in a road or something like that, and then the name of the branch that we're on, and it's green. Then when I change README, I get it's orange now because it's no longer all up to date with the remote repository or the version I've got here. So something is different. And you can see it's got a circle. And what that circle means is that I've got changes that I haven't yet been prepared to commit. When I added it, and so it became something that was changed and ready to go in. So you can see here I did git add readme, and then it changed to a plus. And what this means is I've got stuff that needs to be committed. So that needs to be that needs to be committed. So I've said these things are going to be added to the repo. And then when I changed transcoder.py, and I was in this position where I had something that I hadn't staged for commit and something that I had staged for commit, I got both. Okay. Now, the difference between being staged for commit and not staged is these things here that are just modified. It's just what I'm working on. Okay. So this tells me that, yeah, I've made some changes at this point to transcoder.py, and I haven't really told Git what I want to do with them. When I add it, I say, right, I want you to record now that is part of this next batch of changes that should be saved into the repository. So what do I do next? Now I've got all of those changes staged. Okay, so these are to be committed. I can do git commit -m to say that I want to provide a message. Press enter. Okay, and you can see now that this goes back to green because the repository has recorded the things that are there. So this is what we did last time, and this is just, you know, recording the local changes. You know, things are here. It doesn't change what's going on with my repo. So if I go back to here, those changes are not reflected in this. Okay, so what we would do in order to make sure those do go there is we would push these changes back. And we can do that simply by typing git push. Okay, now it's going to ask me for a username. And this is why I haven't turned on the thing yet, because I realized this is the one that is going to ask for my username. So I type in a username and my password, which I'm just going to type one character off first just to make sure it isn't echoing. That's okay. Swordfish, there you go. Now that that's been pushed, you can see it tells you where it's going and what's happening. If we look over here, press F5, you can see you've now got James Shuttleworth and James Shuttleworth, and we've got the changes. If we're going to source, you can see transcoder.py was updated with important things. We can even look more closely at this so we can see that full stop that's there. If we look at the history of the file, we can actually see the most recent update, and we can even, if we want to, look particularly at that change so we can see what happened, and it gives lots of information about what's going on. So that change included these two things. It changed this to this, and this had that been inserted. Okay, so you can see everything's there. That's all we need to do to make that work for now. We will use things like pull later, so when you've got multiple people working on things, and we'll go over that. But for now, all you need to do is to push the repository. So that's our first part. And what I want you to do is your first breakout is to do that with your code, to make sure it's checked in, pushed, and you've gone and looked at your copy on the web, and it's there. Okay, if you don't know how to get to your copy on the web, log into github.coventry.ac.uk, go to your profile, your picture, and then click your repositories, and then you should see your, well, maybe in this case, one repository. Okay, and you can see here it says forked from CUEH transcoder. So that'd be this one. You can see I've got many repositories. And there we go. The other thing I think is really interesting is that it says this branch is 1 commit ahead and 3 commits behind the master. So when I made this fork, it has been updated since. Okay, so little odds and sods have changed. Nothing major, but things have changed. So you can see how it relates to the original. That's everything. I think. Is there any questions on that before we call the breakout starting?
There is one thing that was brought up, which I've kind of called you on before, which is vague GitHub messages.
Yes. So you should give good messages. I was giving a fake message, which is meant to go with some actual important changes. But let me just somewhere that's locked so quickly. But yes, these are. This is not a great one. That's also an example. So it was done as an example, so it was there. But yeah, a lot of these are actually correct type of things.
I might actually overdo my messages, because what I tend to do is write what I've done and what I've thought to do next. So I always have like a section of, I don't know, fixed this session, made it faster, or got rid of, X bug to do next, do the next section, and you'll see like a long list of me doing and what I'm going to do next over like the course of the history of me working on a project. You don't necessarily have to do it quite that much, but at least the first part, letting people know exactly what it is that you just fixed and why the commit was necessary, that's the bit you should be doing.
Yes, the next bit I think is an interesting one. That's okay if you're working on your own, but might get a bit confusing if people are seeing other people's messages.
That's exactly it.
This is quite a useful thing if you're working on like for me, you probably won't necessarily look at this for yourself, but this network thing shows me sort of where everyone is with their checkouts and pushes. So as people do stuff, I can see like their thing move along. But the good thing is you can also see the relationship. So you can see here that these two people were sort of obviously working on stuff, and one actually merged code from another. So they've been doing some fairly advanced stuff. And Hayden's one of the people that contributed to the repo with the module stuff. So obviously he's used to using Git. But you can see it's quite handy for sort of the information that you get out of it. And here are all the people doing the forks. Someone has forked my fork rather than the original. So that's interesting.
People are asking, can you use GitHub Desktop? Yeah, you can do it. It's a more visual version. It's good to know the command line stuff.
Just don't ask me how to do it in GitHub Desktop.
Yeah, there's also other programs that are associated with GitHub desktop, a bit like GitHub desktop, like Gitkraken and such like that. It's exactly the same principle, but you know, all of this stuff.
Oh.
For some reason, people have decided to mute me, abusing their power.
I can probably turn off the power to do those things. It's just sometimes it's quite useful for people to be able to like mute someone noisy, especially if we go to breakout rooms.
That's very true. Yeah. The one thing that they did want to see was the command line stuff that you did. Again, if you could just share your screen and show them the bit.
Yeah, no problem. In fact,
does Git add star update it all? Yes, but it's bad practice.
Yeah, so generally you want to pick things that go in. The thing is, if you do add star, you could be adding a bunch of things that, you know, temporary files that you've made and all sorts. So I mean, if you know for a fact that it's not, maybe you could do that, you know, or maybe you use, you know, star.py if you want to just make sure all your source code files are in there. But it's unlikely, particularly on first year programming module, that you're going to be using something so complex that you need to worry about adding things with wildcards. We'll see, maybe by the end.
Jennifer thinks that she's messed up her commit history, and Mohammed would prefer to speak to you privately about something.
Okay. We haven't really got time for us to do private chats in the middle of the live sessions, but yeah, if you send me an email, we can organise something for another time.
Yeah. Yeah. Otherwise, they just want to see the commands taking some people are saying, do we have to do it now? You don't have to do it right now. You know, nobody's forcing you.
No one's forcing you. It's just it's quite useful to be able to say, go and try this stuff out. So we'll do the breakout in a second. Go and try this stuff out. Come back, yeah, when you've had a go, and then you've had a chance to have some supported time doing like your first Git push. Yeah. Okay, so. Just going to again, you've already done the Git clone and that kind of stuff, so I'm going to go into my copy. Git, now, tell you what, let me put that thing on that I kept talking about, if I can remember what it was. Show the keys. Damn it, I forgot what. Oh. Where did I put it? Screen key.
Ah.
There we go. I've tried a few things.
That's fair. Because you do want to see what looks good, don't you? That's cool.
So what I'm going to do, I'm going to just keep that minimized. It'll pop up across the bottom. So what I'll do is I will also resize this so that my terminal doesn't go over that bottom portion.
I was going to say that because that's the only drawback of having a band across your screen.
Yeah. There we go. Okay, so LS, I can see the stuff there. Git status. So you can see on screen you've got the enter, you've got space, so some of those special characters. That makes sense, I think. Nice and clear. So here we go. There's nothing in there. I'm now going to edit a file. So let's say I go into the source code directory, and you can see I press CD space SR tab. That was possibly the laziest tab completion ever because it literally was one character. However, I've got so used to using tab completion, so it writes the rest in for me, that's just habit. Okay, so when you see that, it's me pressing the tab key because the shell will try and help me to write the rest of it. And you might think one character isn't worth it, but like I can get to the tab without actually having to think at all, whereas getting to C requires actually finding the key. So even if you can touch type, which program enough, you sort of do it almost by accident, there's still that sort of extra movement time when you kind of in the shell as a more advanced user or someone that's been in the shell for a long time, you kind of have a little finger hovering near the tab key almost constantly. Yep. Okay, so have a look. I'm going to edit transcoder.py. So there you go, TR and tab. We'll get the rest. So there's a much more useful version. Just move that up a little bit. So let's say I'm going to make some other kind of change now. So I'm going to go for let's say I'm going to start writing my as ASCII function. Okay, so I'll put it somewhere at the top. you want to put in some comments. Save and out. Okay, so I've edited it. You can see that I've now got the orange thing and the circle. The circle means that I've got something that is changed but not yet staged for commit. Git add, and the thing that I want to stage for commit. You can now see I've got a plus, which means I've got stuff that's been added but not committed. Git status will show you what those things are. It's still slightly over, isn't it? There you go. Git status, just put that for extra space between those two things. Shows me that. Git commit -m, and just because it's going to wind Adam up, I'll put the message as things, things and stuff. There we go. And now you can see this has gone back to green because the stuff that's here has been checked in. So I can tell instantly when I come into this directory, what condition things are in. Git status will show me what's there. There is nothing left to go. It's all fine. But it also tells me that your branch is ahead of origin master. So origin master means this branch master, wherever it came from originally, which is our fork on the remote repository, github.coventry.ac.uk is where it is. So if I now do git push, just like it tells me, it will ask me for details here. So let me just go and kill that. No. Again. Does not want to die now, does it? Okay. Actually, this is one of the best things about Z Shell is the completion on stuff like this. Show keys, no, screen key. Up in there. Oh, so it's written in Python, which means I obviously have to kill Python. Okay, ignore everything that just happened between me saying, let me just kill that and that. That was me sort of realizing that was a tricky thing to get out of. There's probably a better way to do it, probably one built in. I've never used it properly before. So there we go. Swordfish. There we go. And now that should be up on repo. So I'm going to put this back on just there. Transcoder. Things and stuff was the last commit. You can see it's related to this. It only shows you this log on the things that change. So yeah, you can see where the last change was for stuff, and there it is. So that's the demo. We're now going into a brand new. Is server in? We should have server back today. I can't see the list.
I was going to say there's enough people that I can't see the list. Are you here, server?
Yes.
So Michael, how do you get rid of the chat notifications? If you go into Teams proper, click on your icon, you can go to the cog in options, notifications, and turn off everything that you don't like. That's the way to do it, and then it won't drive you mad. I had to do that the first time as well, and every time I go into a new lecture, basically I have to do it again. So
okay. Right, so we're going to go to the breakout. You can still carry on asking questions. Go to the same breakout rooms that you've been going to before. We will do the same. So there, just take 5-10 minutes. Doesn't need to be a long one, but use the time to try your stuff out if you haven't already, and then you can ask questions so that you've got a smaller group to ask the stuff in, and it's easier if you want to show what your screen is doing. We'll be back here. I'll go to 12:40. So if we say 12:50 at the latest to be back in the main room. I think I went for 1, Adam was on 2, and server would be on 3. If you have any reason why you want to switch from one group to another, that is absolutely fine. The only time I would try and reorganize this is if it turns out that everyone's in one or the other, or one of them's empty.
That's true, yeah.
But if one person wants to move across to a particular one because they've been working with someone, don't worry about it. Just go for it. It was completely arbitrary in the first place. Right.
Do you want me to go to 2 then? Because I was in 3 before.
Oh, you in 3? Sorry.
Yeah, I don't
Whichever
mind.
way around. So you can, stick to the one you're in. That's probably the easiest for consistency. So server would be on 2, and I'll be on 1.
Okay. Right. See you guys in a minute then.
See you shortly.
Oh, when are we coming back?
At 10:02 at the latest.
10 minutes.
Try and keep pace on this one if I can.
Yeah, cool.
Yeah, boy.
Right, I think I'm back. Can you guys hear me all right? Sweet. Has anybody got any questions that they want to ask in chat or want to message me directly? I'd prefer in chat during the sessions just because it's easier. But for me to not have to jump. But feel free to message me directly and I can get back to you after the lesson as well. Any questions?
Yeah, I do have a question.
Sure, go for it.
Thing is Solidity good?
Is what good, sorry?
Solidity.
I've never heard of it.
It's like a blockchain language.
Okay.
It's pretty much like developed on Ethereum at the moment, and you can actually make contracts, communicate with like wallets and everything, all that. It's pretty much imagine C++ on steroids,
Okay.
combined with Python, Java, and everything, pretty much, yeah.
Sounds very cool. Send me a message directly. I know almost nothing about blockchain, I'll be honest with you. But if you send me a message just with it in so that I remember, I will go and investigate and I will give you my professional opinion, I guess.
Yeah,
But,
sure.
but yeah,
I'll
I don't know
DM
now.
you.
Okay, cool. Sure. Navdeep has a message here. Can you advise me on the commit M? It keeps saying, "Tell me who you are." Okay, so it just means that you guys aren't logged into Git, right? So if you're getting a "Tell me who you are at something," it just means that you haven't set it up on the command line. I think James might have overlooked that that's an instruction that needs to be done. We will find the information for you and make it available. I'll talk to him as soon as he gets back and we'll go through it, okay? So that you've got it all on the video and stuff. Somebody else with their hand up? Do you want to say something? Unmute yourself and ask a question. Any more questions in chat? In Firefox inside the Linux login, I've got to be honest, I'm not sure why you would need to log into Firefox inside Linux to get into Git. I might have missed something else in chat though. Ben might have got your back here with the git config global user, your username stuff. I think that's pretty much it. How'd you get on, James?
Fine. Yeah. So if anyone does get that message, I've just said someone into the same thing. If it wants to know who you are, and it says I can't commit to that who you are, it actually tells you what to do. And just like Ben's put in there, you just literally type those things in, except put your username and your name in, and then it will remember who you are. And all it is so that it knows who to blame in the logs, if you like.
That's exactly it. Marco, do you still have a question? Because you've still got your hand up. Ask away, my friend.
Yeah, so what I was going to do was we're going to do a model solution or something similar for Transcoder, and then we'd have a break, and then we'd move along.
Yeah, so we'll do some introductory stuff first, and then smoke break. Sound good?
Yeah.
If you do disappear for a smoke break, it is all recorded though, so you know.
Yeah, not your smoke break. We don't record.
No.
Also, Mark, yeah, the next sort of 10-15 minutes, we're going to be doing the model solution for Transcoder. So if you're done and you think, actually, I know that, I can just come and watch the video later, then yeah, you don't need to stress about it.
For those of you who have just joined, all we've said is that if you're getting the same error message that says like Git doesn't know who you are, it does have commands in there for you to follow. Ben has put something in chat which literally says git config -- global and then user.name and such. Follow those directions. Yeah.
And if Git needs you to do that, it will tell you. Like it'll actually pop up and say, just type these things in so I know who you are. And you just do that. But obviously, don't use the example things.
Yeah.
Oliver, you've got your hand up. Oh, put my hand up now. Oliver, you've got your hand up. Is that if you've got a question?
So I have been asked something privately, but I think it's worth saying out loud here. People have asked if they can miss this session. They've got other things that need to be done. Like if you do need to miss a session, this is why we record it, so that you can go over it as often as possible. You know, we're not here to police you or make you turn up. Obviously, if you turn up, you're going to get a lot more from these sessions. But if you need to, for whatever reason, you know, not turn up, then we can completely understand. Just try and catch up in your own time. All right.
Yeah, the other option really for modules like this would be to just have recorded videos and then have drop-in sessions and stuff. But I wanted to have this live bit so that we could sort of, for parts of it, get people sort of moving along in one direction. Okay, so whoever just posted a picture now, look at the picture, it doesn't tell me who posted it, but whoever is Hussein10, it's because you missed the quote off on the end, and you could probably just put the double quote and press enter. It recognised that you didn't finish it, and it's trying to say, look, you need to finish this off.
If you do get stuck once and stay stuck, that's okay. That's the other reason for the sessions being recorded. It is literally so that if you get stuck, fine, put down following along and just listen, try and absorb as much of the information, and then go back and do the practical stuff at your own pace and try and get over it. Get over that hurdle that got you stuck. And we're about for questions at any time. So if you do get stuck, throw out the questions and we'll do what we can to help you.
Right. It's also why we have those breakout sessions, so that you've got a slightly smaller group to get that sort of support stuff in.
Yeah.
So, okay. I'm going to move us along to the next bit so we can get to break. So someone mentioned, we didn't really have structured breaks. I have put structured breaks in, so we'll definitely have one of those, even if it runs a bit long, because I've put sort of stuff in at the end which can be squashed up a bit, or we can carry over, and it's recorded. If we need to. Actually, today we are going to finish at 3 because I've got a meeting at 3. But we'll work around the breaks and things. So there will be one coming up. But I wanted to do a quick demonstration of how I would have solved at least the basics for transcoder. Okay, so I'm going to share my screen now. So the nice thing is, because I've got my checkout already, my fork and my clone of this here, I can just work with that. So let me have a look at the code. I'm going to switch to Emacs now because I can't keep using Nano, drives me around the vent. So
you guys use Nano.
Yeah, or whatever you like.
Yeah, whatever you like.
I know we've got quite a few people using Vim now, so
some people might actually genuinely want to take this opportunity to learn Emacs as well, which is not a bad thing by any stretch of imagination. Just know it's hard mode.
So there we go. Remember, we got to this point, we put the as ASCII, and we've got the stuff there. I'm a big fan of sort of but basing code on other code and sort of working through that way. So if you work like that and you want to go, well, actually, it's going to be very similar to how this stuff works. So let's start with that. Seems reasonable. Okay, so let's put that in, and then I'll talk you through how this works and what we need to change. So as ASCII, we start off again with this output equals an empty string, and you see this in a lot of code because it's what we call an accumulator. So you put this there, it starts off as empty. It could start off as 0 in other cases if you're doing something with numbers, and then you add something to it as you go along, or you modify it as you go, and at the end the result is in that output, or whatever you called it. Could be called out, could be called sum, could be called, you know, accumulator, whatever. In the case of this, it's the string that we're going to output. So I said output is equal to empty string, and then here, well, this moment is doing octal, and if you look, what it does is it does these things get added for each character. So for C in data, which will go through every character in the data that comes in, the output has added to it a space plus oct ord C. So this bit happens first, so I'll highlight it, ord C. And what that function does is it gives you the ordinal for a given character. Right, the ordinal is the number for that character. One of the things that you can do to test this stuff out is you can actually run Python and you can try things. So ord of A should give us, hopefully everyone's shouting, 97. Ord of capital A, 5. Yeah, so these are the ASCII codes for what we want. That then is being passed into oct here, which is the octal function. So it returns the octal representation, and we don't want to do that. We just want this part. The trouble is that this bit here is a string, and this bit here will be a number, and it doesn't like that. So we've got a couple of options. We can either use the str. So here we saw, let's say, oct 12 gives us 12 in octal, which is 14, or 1 4. It's not really 14, it's still 12. And str 12 gives us the string containing 1 2. So these functions just convert data from one form to another. So we could do this, and that actually works. That's enough to solve that problem. Or we could use f strings, which is a slightly nicer way to do it. So we could say this has added to it that. Okay. Yeah, that. So you can see here we're using the f strings functionality to put this ord in here, and that automatically turns things back into strings. We should test this. So the first thing we can do is we can go to our unit tests, and you should see that there is a test as ASCII already written, if you remember. So I'm going to uncomment that. I uncommented it, and now it should be ready to go. So I'm going to go back to a directory that we're in. And make test. And if I've done it right, oh, there we go. Message about not being inside the virtual room. So let me, did I make it? No, so make remove. I forgot I deleted the one I was using before and got it down again to just today, didn't I? So make, let's activate it.
I was going to do then do prereqs. Don't
Make
forget the prereqs. We're debating what the most hardcore version of programming is. Apparently, you can program everything that you want in Scratch now, which is interesting.
Well, if it's Turing complete, I mean,
yeah.
Personally, I prefer Excel macros. So I've got to write everything in Excel macros. No, I'm joking. Right, so this is the trouble. The videos end up with diversions in, and even though I can't see the comments, I've now got Adam giving me the choicest comments to respond to. So I'll try not to. Right. So done thing, make test, and if we've done it right, we should find that everything passes. So the new as ASCII test is passed. Let's just see what happens if I make it slightly wrong. Let's put too many spaces in. Okay, and it tells me that something's not right. And if you look here, you can see there's this assertion that this should be equal to that. So this is what I wanted it to be. I actually got this clearly wrong, and we can fix it. Okay, so that's why the testing is useful. Now we need to make sure that that actually gets used inside transcoder. So in transcoder. So we actually need to make sure it gets used. If you look down at the bottom, you can see I've got hex data, oct data, bin data. Well, let's make ASCII data equals as ASCII input data. Like that. And then we can test the user interface. Okay, so we can test how it looks to the user. So we've done our unit tests. We now can do it.
You have to say right there, like ASCII data, not input data on the output.
Oh, sorry.
Yep, that's the one.
Thank you. Using lazy completion again. Right. Thanks for that. Whoever that was, 10 house points. We don't actually have any way to record those, so I'll get them out whenever. Right, so let's try this out. So source transcoder, press enter, and we've got any text to go here, and we have the octal, binary, and ASCII versions of it. Okay, and there they are. So you can see, and it starts with a capital A, which wasn't accidental. It's because it's easy one for me to spot in ASCII, hex, binary, and octal. It's like a recognizable, character that you use quite a lot. So 41, 101, 1, lots of zeros and 1, and 65. Okay, so that would be the sort of the basic solution. If you're looking at the more advanced ones, we talked a lot at various points about how to do the advanced task. What I will do is I'll put up some examples of that if people want it a little bit later, rather than talk you through it all right now. But what I will show you is just really quickly how we swap this to use user input, because that was also part of it, as one I haven't talked about a lot. So here we've got input data equals this, and all we're going to do is say input and text to be transcoded. So this function displays whatever it's given and then takes in whatever the user types and returns it as a string. So it'll go into input data. So let's run that. So I'm going to put ABC, ABC, and we should see, there we go, it's 4161. So that's the uppercase and lowercase a. So that's nice and easy to test. We can see the 101 and the 141, which is the lowercase and uppercase a in octal. Binary, we've got this one, and can you see the difference between the uppercase and lowercase characters in binary is actually there is a 1 in that extra position, so they're kind of like nicely spaced to make these patterns, those kind of patterns work, and then 65 and 97 in ASCII, so all works well. And what I should do now, and I'll just do this really quickly, even though we've done it lots of times, is git status. Okay, good. Git add source transcoder, and also I'm going to add two things on the same line now. So add source transcoder and test transcoder. There they are. Git commit -m. Do this, git push, and I won't bother. Okay, just because I don't have to turn off my my banner and hide my password again. So I would then push, and it would go up to the repository, and that's it. That's the basic solution, and a little bit of the more advanced tasks. Asim, no, you don't have to do that now. That is just there as a demonstration, so that you now have a documented. If you haven't done it, this is what I would expect you to do, and go from there. Someone's talking about the recordings.
It's all right. That was me. So
okay.
They were just saying how somebody's name got brought up in one of the troops, and I just said, like, because it's not being recorded in the troops, we don't have to worry quite so much about the talking to people directly and bringing up their names. But if you guys have a question, we try to avoid that in these recordings, you know, to give you some anonymity, essentially.
Yeah. Okay. So we're going to jump into a break. We'll take a 10-minute break. I think that's probably as much as we can fit in at this point. because we are 40 minutes, we're about 20, 30 minutes behind as usual. I've tried to overestimate these things and still get it wrong. I'm hoping I get better at this by the end. It's not usually something I have to do, so it's all new to me. We take a 10-minute break. We come back at, let's say, 1:20. At 1:20, we're going to move on to the loops. We'll have a little bit of a break out there just for you to try some of that stuff out. And then strings and also command line arguments. So we'll do a few things. Then there'll be a break before we look at the port scanner.
Yeah. So Conrad, I probably shouldn't have named you, but break for 10 minutes. That's what we're having. Break now.
Yeah.
See you guys in 10 minutes.
That's it.
I'm gonna go and get coffee.
Yeah, me too, actually. Right, I'll see you all shortly.
Get caffeinated. See you guys in a bit. Oh, hello. I tried getting food. It didn't work well. I can't hear you, James.
Too many
There
mute
we go.
buttons.
Yeah. All the mute buttons.
Just tilt your camera so that like you just get like the top half of your face, and then no one knows if you're eating. You can just, you know.
Hello. That's fine. It's fine.
I've just found so I got a message through WhatsApp from Ian saying server's not actually wasn't in group 2. So I don't know how I managed to mix this up. I'm sure he was here.
If not, I've got about 10 people.
Yeah, we'll split them into 2 because he should be back this week, but and he seemed to show up earlier, but I mean, maybe he's having trouble with the connection.
Maybe.
I had trouble this morning. I was getting a bit worried that I wouldn't be able to get in to my own session. But yeah, so Ian dropped in to session 2. So some people got a bonus Ian, which is always good.
Who doesn't want a bonus Ian?
Exactly. And James Fox has been trolling people, telling them he puts his credentials in the file. Well, worse than that, really. I for the port scanner, my laptop broke, my other laptop, a few weeks ago, and I'd got sort of bits and bobs I was doing on the repositories that we're using for this. So for port scanner, I thought, you know what I'll do while it's up and running for a second. I'm just going to just check in and push all the files that are there, and I'll just sort it out later. Forgot one of them was just the complete answer to how it should be done. So I was thinking, bugger. Now I had to go through and reflow the entire Git repository to remove the check-in so that it disappeared. So yeah, and yeah, this is why. So there's been plenty of people that go around trawling through Git repositories looking for things that look like credentials. So yeah, by file name or by the structure of the text, you can kind of spot them. So public repositories that have credentials in them are a thing. So.
Git also goes out of its way to tell you if you accidentally leave authentication tokens in your repositories as well. It says, you know, like you've left an access token here. Are you sure?
Yeah.
Because yeah, there are people who just go around looking for access tokens. They do exist. There was one question. James, do you think it's a good idea that if we sit in these sessions and do the best we can, and then Thursday and Friday come in and get help?
Yes, and also make use of the Monday and Friday drop-in sessions as well. So I'll be running those, and yeah, so Adam's been in some of them, and Dan was in some of them as well. So I can't guarantee who's going to be in all of them, but it's going to be one or more of us. So make use of that. They're the really particularly for this module sessions. So yeah. It's not expected that you just get everything straight away. Yeah, these are recorded for that purpose. Yeah, this is why we chop them up. It's why you get like all that other content. You know, you get links to stuff. You get stuff on the 2 repositories. The Thursday and Friday sessions are the campus sessions. So people that wanted to come on campus, they get drop-in sessions there. They're not essential. You know, you can do without them. So if anyone's not coming to the on-campus sessions, you know, you can still come to the drop-in sessions that we have on the Monday and the Friday, same as everyone else. So that's where we are.
Yeah. There's also, if you guys want to, you can get in contact with us directly, and we might be able to run sessions, time permitting. I mean, it'd be lovely if we could get around all of you, and all of you could have one-to-one sessions if you needed them. That might not be entirely possible, but we'll try where we can. Do you know what I mean? A lot of people are talking about how fly their laptops are right now. That's showing my age right there, but about how great their laptops are, and discussing the price of Nescafe apparently. So
all key things.
What I would say, legitimately, when it comes to laptop stuff, there is a few things that I look for in a laptop. If that's the nature, the kernel of the reason why you're asking, and you know, first things first, good processor, more cores the better. At least 8 GB of RAM, but preferably 16, and about 1 TB of storage. It doesn't really matter about graphics for this course because you won't do crazy things. We're not doing massive hash table stuff, are we? Or like incredible brute forcing stuff. So you don't really need a huge amount for your laptop, but obviously, you know, the bigger, the more flashy, the more you can flex in front of all of your pals. So
Yeah, and I think when it comes down to it, there's like some things give you a bigger boost than others. So like yeah, if you've got 16 gig of RAM, or even 8 to 16, that's quite a big jump. But 16 to 32 is probably not going to make a massive difference for a lot of the stuff that we do. Whereas if you move from a mechanical hard drive to an SSD, just any SSD, doesn't have to be PCIe NVMe M.2 craziness, makes an enormous difference. This stupid laptop that I'm running on now, because my other one died, is one of the ones that we've got a batch of them at work for. It's not a bad laptop at all. It's an i7 hexa-core. It's got 16 gig of RAM. It's got I forget what's in there now. It's an RTX 20 something. I can forget which one. But yeah, it's like not bad spec, but it runs on a mechanical hard drive, which means that starting stuff up, things is really slow.
are we having a funeral for James's laptop? I feel like we should.
Well, it's going to come back. So it's less than a year old. It was a custom PC thing. So the innards are all like great. It's running on multiple NVMe drives. Like it's got 32 gig of RAM, octa-core, all the good stuff, and an RTX 2080 in the laptop. But unfortunately, I think somewhere along the line, the quality of the case suffered. The contents are great, but the motherboard is not so much. It will come back, I promise.
I've not had much experience on hacking with a MacBook or even MacBook specs, to be honest. So I'm not really adverse to that. But I tell you who I'm not versed in it, I should say, not adverse. I can't really recommend MacBooks or but I have known people that have used them. So it's got a Linux kernel. So I mean, you're already halfway there towards a great laptop anyway.
And this is why I don't worry about the graphics card in my new laptop that's coming.
There we go. That's some flexing right there.
Oh yes. So it might not be quite as good as the 3080, but it's a darn sight more expensive.
Oh yes. We're still waiting on news of the Chromebooks. They are coming.
They are.
At the very least.
But I have news. So
okay.
I spoke to Fazana a couple of days ago. She said that they were hoping that they'd be on campus this week. So then we'll work out what to do with them from there. So distributing them is the next problem, but we'll work it. I know they're cheap now, but like their release price. Anyway, I'm not going to get drawn into graphics card chat.
I'm sorry. Are we going to have like the Chromebooks like ours? Is it going to be ours?
Yes, it will be yours.
Like forever.
Yeah.
Yes.
Forever. Yeah.
The only time that it might be an issue is if you drop out of the year before you're having to pay full fees. So I can't remember what the date was, but like if you drop out before a certain date, you get a portion of fees back and things like that. For people that don't actually turn up or whatever. If you've collected a Chromebook by that point, the university will be sort of chasing you to try and get the money back for it. Pro tip: they don't chase that hard, so it's not. I wouldn't worry about it particularly. But yeah, that's the only thing. So I've got a meeting with her after this session. That's what I'm doing at 3. That's why I have to actually make sure I finish at 3. Is I'm going to be meeting with her again to work out what we're doing about actually getting stuff there, and also for distributing things like the CompTIA vouchers that last year's third years still didn't have for some reason. And some people not so far away from us right now might be quite pleased now that that's also getting a little bit closer to being resolved.
Yay.
Yeah, I mean, exactly.
Stealth. Low key excited. I want my voucher.
Yes. Anyway, that's that. I'm gonna. Okay, I can see 2 people with hand up. So Marco, I'm guessing that was your question done, or do you have another question?
Yeah, that was my question. Sorry, Mike.
No problem. And Oliver, you still got your hand up. I'm not sure whether that's still the original hand.
One thing I will say, guys, we don't know what the specs are on the Chromebook.
I do. I just can't remember what they are. They're not bad. They're not bad at all. They're Lenovo ones. They're actually quite decent.
I kind of rate Lenovo as a laptop creator, actually.
Well, my the laptop I'm waiting for now to sort of do me over instead of this one while I wait for the other one to get fixed is a ThinkPad. So
I like the ThinkPads. If for no other reason they're aluminum, like they're not plastic. I've dropped them so many times because they're so light. It's worth having aluminium chassis.
I'm wondering whether I'm actually going to use the little red nipple though. Like I'd always wonder whether people that have them actually make use of them, because it's like, just seems like I remember having a laptop like as a kid and he had one of those on. Anyway, someone did ask how much they go for. I think they're about 300 quid. So.
I won't lie to you. First years in my year, a lot of them decided to resell as fast as possible. I mean, you know, it is your laptop. It is your laptop, so it's completely up to you. But a lot of them regretted it. A lot of them very fast.
Especially when you go, right, so we know you've all got a Chromebook, so here's a good way to do this and do it easy. So, no, yes. Actually 119. The whoever gets to the pile last doesn't actually get one. No, it'll be everyone, Jack.
Yeah, it is everyone.
Yeah. Exactly. Free laptop is just on the server. In fact, it's one of the easiest ways we can make sure everyone's got like a Linux box they can carry around with them. Okay, right. I'm getting carried away with that. I'm going to move on to the next thing we're on a time limit. I mean, technically, we're on a time limit every week, but this week I actually intend to finish at 3 rather than 4:30 or 4:45.
You do have things to do, don't you? So,
yeah. So the next thing I want to do is I want to do a little bit on loops. You've seen them already, and there's plenty of information about them on the site, but I wanted to show you just a few of the ways that we can build loops and some of the things that are handy for us to do with loops in Python. Okay, so it's going to be just sort of building up some little examples. The next thing we'll do then is strings, and they'll actually sort of see how they're actually useful together, as you've already done, and then we'll do input and output. No, input and output. We're going to do command line arguments. Okay. So I'm going to share my screen.
We can see it.
Excellent. Okay, so
the password is swordfish. There you go, people. You got a password.
Had to happen at some point.
Yeah.
It's my actual password is swordfish with a number on the end, and no one's going to guess that number.
Not in a million years. Not with 100 guesses.
100 million guesses. Right, so what I'm going to do, I'm going to make this. I'm not going to put in a repository. This is just me writing some random bits of code. So I'm going to make a file. I'm going to call it counter for now, because we're going to write something to count the number of times a particular thing occurs. Okay, so that's what we're going to do. The first thing I'm going to do is I'm going to make some data that we're going to work with. So let's say A equals, and then some random text. Now, if we're doing really tiny bits of code, this kind of stuff is fine. Okay, you can call it A, you can do it. If this is going to be something larger, calling it A is exactly the kind of mistake that I regularly make, because in a week's time, when I'm still developing this and it's 100 lines of code longer than this, I'm starting to wish that I'd changed that, and now I've got to go and find all of the A's and refactor and do things. So really, why don't we call it something sensible now, like data? Okay, and we know that this is the data that we're processing. The other thing that I always end up doing is I start writing the code, and then we should put in a function. So I'm not going to do that today, so I just don't want to complicate things. But quite often, if you know that this is something like, this is a bit of code that will count the number of values, you know that really you need some boilerplate around it. How we're going to get those values? Is it going to be a menu? Is it going to interact with the user? And you don't want it all just lying around. You want a function to call that does that for you. But for now, we're just going to leave it where it is. So data is this, and you've seen this before for C in data. This C could be anything, so I could call it character in data. So now when I refer to character, I'm referring to each individual thing. I'm actually a great believer in using single letter variables for loops, and when they're very small, because for C in data, for a small loop, it's very easy for me to see that C is that character. And it's also a lot closer to the kind of notation you might use in maths. Okay, so in this course, in this module for sure, but in this course in general, the kind of software we're writing is not really going to be that close to maths. In other areas, you do quite often stray between sort of programming and maths, because discrete maths and the things that happen in there are very closely related, and also a lot of what we do is implementing things that come from somewhere. So let's say, for example, you wanted to work out which person's record was closest to another person's record. Actually, one of the ways you can do that is to use Euclidean distance by taking the difference between all of the fields. Okay, now you might not think it, but that means you're basically going to be doing a bunch of maths to work out whether person A and person B are similar in any sense. So things like this, they do translate across. So anyone that's sort of got a mathematical background, does tend to go with these single letter variables. It's up to you. Okay, the whole point of that spiel is I called it C, but I could have called it anything. C for character in this case, because it makes sense to me. If it doesn't make sense to you, feel free to call it somewhere else. Just don't try and call it things like CHR, because there is a function called CHR. And if you try and use any of the function names, you can do, but it might cause you a lot of confusion later. A classic thing is you call something one of the Python's function names in built functions like print or char or something like that. And then later when you try and use them, it doesn't work because you've just changed what they are. Okay, but back to the loop. For everything that's in there, what I want to do is I want to work out how many times the letter J appears in that string. Okay, so I know I can look and see what the current letter is. So let's just say if C is equal to J, do something. I'm going to put pass in for now. Special word in Python that means, this is where I would put a command, but I'm not going to. Else pass. Now I just want to point out the indentation. All right, this has been mentioned a few times, and it's mentioned a lot in the quick start guide as well, and every Python resource. But when we want to have a block of code that is protected by some other line, and by that I mean in this case we have for C in data, which means we're going to do some stuff a number of times. That's our for loop. We indent that stuff. So here 1, 2, 3, 4 spaces, and then the thing. That's good, right? We can see where those things are. If you want to, you can use tabs, but don't mix them, right? So don't use tabs sometimes, spaces the other. Personally, I prefer 4 spaces. So in Emacs, when I press tab, it will actually put in 4 spaces for me. Okay, so it lines stuff up. But then we've also got if C is equal to J, we do some stuff. Now we could have more than one line in here. So it could be that we've got, print something. We could have, some assignment. All of these things that are indented now are controlled by that line. So this block is only executed if this is true. And if this isn't true, then this block is executed. At the moment, that block is one line, but again, could be multiple lines of code, right? SDF is not actually a valid Python command, in case you're wondering. So what do I want to actually do? Well, if I wanted to just display them, that's one thing. So I could put them out. So I could perhaps capitalize all of the J's. So let's say out is equal to this. Remember I talked about accumulators. It's a very common thing. So if C is equal to J, out has added to it. So plus equals, or out equals out plus is the longer form. So I'm just going to go out plus equals. This means add on to the end. Out equals out plus. It's a shorthand for a capital J. And if it's not equal to a J, out plus equals the character. So that's a C. Notice we've done this before, but just as a reminder, this has quotes around it. This has quotes around it. This one doesn't. So this isn't the letter C. It's whatever's in the variable C. This one is the letter J. So it's literally the letter J. We call it a literal. Okay. There's all kinds of things that aren't great about this program. It works only when we're looking at lowercase at the moment, and it's just it's not particularly useful. It's the other thing. I mean, why would you want this? But it does demonstrate loops and how to use these if statements. Okay, so outside of the loop now. So going back a little bit, I'm going to print out. Shebang. And Python, as we always do, into terminal. There's my file counter, chmod u plus x counter, and run it. And you can see, hopefully you can see, that the J's have now become uppercase. So every time I saw one of those, I did this. So there we're seeing the output, as that string almost, but with some box changed. That's not really counting them. That's just proving that we actually got sensible looping going on. So instead, what I'm going to do is I'm going to have a count, and it's going to be equal to 0. And if we find a J, I'm going to add 1 to it. Again, I'm using that shorthand, count plus equals 1, but I should write it out fully as count equals count plus 1. Okay. Programmers are lazy people, right? So it's being lazy in the right way, not just not programming, but writing fewer lines of code means fewer opportunities to make a mistake. So I like writing count plus equals 1 because every extra bit that I write is a chance to make a spelling mistake or some other typo. So what does this do? Well, this, instead of using out as a string, it's now got something that I've called count, which starts off at 0, and every time it sees a J, it goes up by 1. Okay. So let's try and see what we get now. That seems right. Well, let's have a look. 1, 2, 3. Yeah, seems to work. So this is a very simple loop. We can do various things with it. We could improve this by having something like a target like this, and then saying if C is equal to that target. And then what we can do is we could make that instead a D. And we count the number of Ds, or an S, count the number of S's, let's count the number of Gs. Hopefully one of them's not going to be 4. Ks, 3 Ks. Okay. Oh, there's only U. Let's try that one. Yeah, we go. There's only 1 U. So you can see, how the loop works and it goes through. Now, quite often we do this. We have this list of things, if you like. This string here is the things that we want to go through. But many times we actually just want to go from something to something else, like a number, right? So 0 to 100. And if we wanted to do that, we can use something a little bit different. So I'm going to change this now. This loop instead for I, because I'm using that for an incidental variable. It's a really classic variable name for a loop counter. For I in range 100. Anyone that's written anything in pretty much any other language, that's not peculiar, would be used to seeing something like this.
It's very C languages. This is
C, Java, C++, Pascal, and a load of others. You'd see loops done like this. And here you say I is equal to 0, and while I is less than 100, keep adding 1 to it. Okay, that isn't what's happening in Python. Okay, it looks similar. It says for I in range 100, but what's actually happening is this range makes a list of things that's 100 long. Okay, so it's not very helpful now because I have to do it like this. Okay, so it actually makes this list of things that's 10 long. Notice in this, I didn't do 100 just because it wouldn't go off the edge. But here, notice that it's 0 to 9. Okay, so this is up to but not including 100. So it's effectively 100 values, 0 being the first one, 1 being the second one, 2 being the third one. So, okay, let's just print out I, just convince ourselves that actually works. So run the program and we get the numbers up to 99. So really, really useful loop. The other sort of loop that you see quite often is a while loop, and this works very similar. So again, if you've used other languages, you might see something like while A equals is equal to B, or while A is less than 100, or whatever. In Python, looks very similar, but we just don't need the extra brackets. So we might say while true. True is a Boolean. It means it's a value that can be either true or false. And we obviously here mean literally true. So this will always run. So while loops run as long as whatever's here is true. So if you put true in, it runs forever. Demonstrate that. Just move that out of the way. Counter, and yeah, still true. Okay. while 1 is greater than 0. Okay, so now I'm actually putting an expression in there that leads to true or false. While 1 is greater than 0. So, yeah, that's still always true, right? That's if ever that becomes untrue, then I need to find a different job. A slurp of coffee. The next thing we'll do is what happens if this is not true? Well, 0 is greater than 1, or I could just switch to end you 1 is less than 0. So what happens here? Nothing, because that's never true. Okay, so at the moment it's actually really just acting like an if statement. All right, it's not really doing a lot other than making it an if. What's different is things like this. We might say maximum equals 100, counter equals 0, and then we might say while counter is less than the maximum. Okay. And inside this loop, we're going to add one to counter. Okay, so and what you see is 10 times that works. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it comes out, which we could have done another loop that does the same thing. And the reason is we know that this has got a fixed number of times it's going to finish. Okay, so we know where that's going to go. So for loops are really handy for that. If we know we've got a fixed list of things or we have a fixed number of times we want to do something, a for loop is great. It's very expressive. This while loop at the moment isn't really giving us a lot extra. What is handy is when we don't know when those things are. Okay, so for example, we might do something really simple like taking user input. Right, so let's try. We might say something like let's just put hello in there for now, and then user equals input, enter command or quit. Okay, let's see what happens with this. So we get hello, we type stuff in, and we type quit, and we quit. Okay, so we can use this to run stuff as many times as necessary. Yeah. Another thing you might do is you might actually have some sort of variable that you control and you want to sort of refine it. So you might say, well, you know, I want to double a number and see how long it takes me to get over 256. Yeah. So we might say count equals 1, and we might say, well, count is less than 256. We'll print count and then say count equals count times 2 or count times equals 2. I'm lazy. And we get 1, 2, 4, 8, 16, 32, 64, 128. The next one would be 256, so therefore it won't display because this says, well, it's less than 256. If I said less than or equal to, we get that 256. Okay, now obviously you can calculate those things, but you don't. Maybe you have a different starting point. Maybe we have a random starting point. So we could do random, not random, so import random. It's a useful function if you ever need to get a random integer. So somewhere between 1 and 9 will be our starting point. And we run it, and each time we run it, we get a different starting point. The number of times it executes the loop is different. So those are our while loops, okay, and that's the number of times we go through. One of the things that I think is useful here is that you see these everywhere, but you very rarely get to try out all the little bits and pieces. So you know there are things like, you know, we'll come across later how to break out of loops, how to do things that in loops that haven't been broken, how to skip on to the next version, but we'll show you those as we need them, because I've always found them to be slightly confusing to explain if you don't need them yet. Okay, so when they're useful, we'll tell you about them, and we'll give you some of the advanced stuff that loops can do in Python. Okay. The other thing that I wanted to make sure to point out is if you look at the repository and you go to iteration, you have the introduction, you've got for loops, which explains for loops, all the stuff here, iterating over ranges, nested loops, so when you have loops inside of loops, which is actually extremely common and very handy, and there's a countdown challenge. Okay, so this is what you can do in your breakout today. You've got while loops, so again explains create a while loop that calculates the Fibonacci sequence, so have a look and as you work that out. That would be something worth trying out. I wouldn't do it today, but that's a good for testing knowledge. And the recursion part, we have a link to it and some more information. We're not going to make a huge use of this at the moment. If we do, we'll put it in there, or maybe it's something we'll just add to in later years. Remember, this is the idea is that this repository is something that you'll keep referring to later in your course, not just this module. Okay, that's the quick intro to loops and the kind of things you'd be expecting. Hopefully not too much of a surprise because they are things that you've seen and you've copied and modified code that makes use of them. Do we have any questions on that?
The biggest question at the moment, there's a couple, but I think I've answered one of them. What does the import statement do? I said it's a statement that brings in the code from the standard, the Python standard libraries, essentially.
Yes, so it's the way that you bring in code from other places. In fact, there's when we get to the example at the end where we're going to show you the port scanner, so starting off with the port scanner, we'll use that there. So it's not just the standard libraries, you can also import blocks of code that your own or from other files.
Can we add to this repo ourselves as well as come up? So
you can. So if you look at the on the introduction, actually, no one's actually contributed to this one. You can do in the same way that in the main one, we have a list of contributors. So these people have all submitted fixes, so typos or improvements to things. Same thing in it's in Transcoder, or no, it was in port scanner. Someone updated one of the things in here. I think it was Idris. So there was a change to what the university was running. So for some reason they started running this HTTPS alt thing. So that was added, and I think someone's also updated the Transcoder repository, if I remember rightly. So yes, all you do is you clone it, right? Because all you got to do is take the pages part out, and you'll find it's a public repository.
One question was that some people are getting syntax errors when they're running the loop. The most common syntax error that I've ever seen from loops is not having the right spaces in the right places. Like if you're doing tab completion, depending on the editor, if you're using Nano, there's a difference between tabs and spaces, and you have to be very clear that you're using them consistently. And perhaps the colon as well. Do you want to show them again, just the right looking for loop?
So there's the while loop, a for loop, something like that. Notice that it's always you have a colon, then everything inside is indented, and I prefer
can't see your screen.
For space. Sorry,
that's all right.
Oh dear, let's try again. Go. So you've got a while loop here, the first part, and you've got a for loop at the bottom, indented by 4 spaces inside. There's a colon at the end of this first line, the same thing you saw when I was using the if. So if true, do something, colon at the end, and then a block of code. In general, in Python, that's what you'll see. If something is inside something else, there'll be an indentation for that block of code, and the line that's controlling it, or the definition in the case of functions. So when you saw functions, they kind of look like this, and again, the end you have a colon, and here you've got indentation. Okay, so always the same pattern.
We've got a question about it also being inside Python shell. So just is it the same for Python shell? So
yeah, so if you wanted to do something inside the Python, so here I'm just running code from a file, just like we've been doing all the way from the start. If you did want to do it inside the Python shell like this, so let's just clear the screen, which is Control L, as you can see now. You can do so for sorry, just about to write a hybrid of Python and C. For I in range 20 tab.
range wrong.
Okay. And it won't work then, but
I was going to say break it and then you can fix it.
Yeah. Right, so there we go. Typo. Let's do that again. For I, why did I do that? For I in range, not Ranagi. Tab. Okay, so it's a tab here because it's it's easier in Emacs. Like I said, it's basically for or 1, 2, 3, 4 spaces. Print I, and there we go. Okay, so once I've finished with the indentation, you'll notice, right, press enter, and it's still waiting because it doesn't know that I've finished that first for loop. I could possibly go in and do something else. So print I to the pair of I. Okay. Oh, sorry, I used spaces on that one. So one is that tab one. Let me just do a tab. There we go. Tab. They've got multiple lines, and when I'm finished, I use the blank line and I press enter. Okay. There you go. So 19 to the pair of 19 is that big number.
Nice.
Big one enough. Okay.
I would say though, try not to use the Python shell because you can't refer back to what you've done in the Python shell. So if you make it a file with lots of comments, you can always remind yourself of stuff just in case you ever want to go over what you did before.
Exactly.
Trust me, you'll thank me later.
And if you make a mistake like I did, it's up to you to type the whole lot in again just to fix the typo.
Yeah, sometimes it's good just to like throw something out there quick, but yeah, I would always prefer a file over other stuff.
Simran, no, you don't have to use the Linux Python version. You can use. We're not doing anything at the moment for this that you can't do on Windows as well. Later, when we look at the port scanner, then there's possibly a difference. It worked on my version of Windows, but I've had all sorts of odd things when it comes to ports and Python on Windows. I don't know whether that's historically a thing, but no longer an issue. But try it, and if it doesn't work as you expect, try it inside Linux. But for the loops, absolutely no reason to worry about where you're doing it.
Yeah. There was another question as well about spaces and tabs that I think is worth talking about for everybody and for being able to refer back to in the video. Does tabs always automatically do 4 spaces? It really does depend on the text editor, guys. So if you use some text editors, that it doesn't guarantee you 4 spaces. If you're not sure, just use spaces anyway. Idle, the text editor with Python, automatically does the right amount of spaces, but it's important to be consistent with your white spaces basically throughout Python.
So some editors will let you do things like this as well, which is show the characters that you don't normally see. So if you look here now, you can see these $signs on the end. That shows me that's the end of the line. So that's just where the carriage return is. And you can see these dots, spaces. So I can see that they're all there. And then if I was in here and it was doing something and there was actually a tab, which would be like that, you can see the tab is there. Actually, I've got it highlighted as well. That's slightly different function just to show that something's different. So if I do a equals this, do that. Can you see that character? That's actually one character, but it's that wide. That's what a tab is. Okay. So personally prefer 4 spaces. I wouldn't go as far as to call it a holy war, but it is a constant discussion. There is a style guide, tabs or spaces. and spaces are the preferred indentation method. Okay. Python 3 disallows mixing the use of tabs and spaces for indentation. Oh, I didn't realize Python 2 accepted it, but Python 3 definitely doesn't allow you to mix it. And this was written by Guido van Rossum. Okay, so if you don't know, that's the guy that invented Python. So do what Guido says. Or not.
Or not. Or not. There's plenty of people who've like decided to go against the grain on purpose, and I guess you guys wouldn't be on an ethical hacking course if you weren't against the grain kind of people.
Yeah, although I feel like this is one that might well troll you later, because all of the source code that you get from me, all of the project starting points are all going to be in spaces. So yeah, TabGang is going to have to do a lot of conversion.
Yeah. Yeah. I mean, there's a lot of people are trying to help in the chat. It's great to see you guys all helping each other. It's like, really, just make sure that you guys are sure that you're giving the right help. I would say sometimes there's been a little bit of misconstrued help, and although it's well-meaning, just double check, make sure you guys are right when you're giving the help.
Yeah. Or if something doesn't work, if you get advice it doesn't seem to make sense to you or doesn't work, just come back to one of us and we can check. Right. I should have another breakout. I think it's worth having a quick breakout for the loops. If we say 10 minutes, because I don't think it'll take you much longer. What I'd like you to do is, if you go to the repo PyQuickstart one here, and go to iteration for loops, down at the bottom. Who's this? See if you can create a loop that can count down from 10, and then once it gets to 0, it prints out the word liftoff. See if you can also make it print that the rocket was successfully launched. So just launch a rocket. Okay, so just 10, 9, 8, that sort of thing. No actual rockets required. It's just the countdown. You're thinking, well, I've seen things go up. How do I make things go down? Okay, there are lots of ways you can do it. So you could use a while loop, start off with a counter that's at 10, take one away each time, and make sure the loop is while the counter is greater than or equal to 0, so that when it gets to 0, that's the last one. You could use a for loop and range and invert it. So if you actually look up Python range, and this is, if we haven't said this already, I'm pretty sure we have, Google stuff regularly, right? Check something. So if you watch any sort of Python programmer or any programmer, they don't remember every bit of everything. All right. Knowing the basic syntax is one thing, having some experience is another, but actually remembering the entire contents of all of the things that it can do and the libraries is pretty much impossible. Okay, so if we're looking for range, ranges, there you go. So you can see range stop, which is what we've been doing. So I've said range 10, range 100, so that's what it stops when it gets up to, but not including. But you could also do start, stop, step. Okay, so as a hint, I'll just switch to I'm just going to do what we said don't do now and use the interpreter, but just to show you, Python range 10, range 5, 10. Okay, so up to there. Actually, I should put make these lists. List. Range 10 gives you those numbers. Range 5, 10 gives you 5, 6, 7, 8, and 9. Okay, so it starts from that one up to, but not including the last one. That's going to happen in many other places as well later. But we can also do 10 to 5 in steps of -1. Okay, so 10, 9, 8, 7, 6. Notice it starts at 10 and goes down to, but not including 5. So it's always, starts from the first one, goes to, but doesn't include the second one. And optionally, you can say how you get there. So I could also go -2, okay, or whatever. Make sense? So let's say 10 minutes. We are currently at, hold on, let me get the thing, 14:04. So we say 14 minutes past. Yeah, quarter past. Oh. Yeah.
14 minutes past and 30 seconds precisely, please, people.
Yes.
That's a second later.
Nothing wrong with being correct.
No, you're right.
Yeah. So I'll see you in the sessions. Since we don't seem to have the third person, I think if you're in whichever one server would be in, feel free to join either one, which is the one that I'm in, or two, which would be the one that Adam's in. They're not busy enough at the moment that it's going to make a difference anyway, so we'll work from there.
Yeah, I was going to say all of my guys come over to 2, and whoever's, because Sever was supposed to be in 2, so I will go over to 2. All of my guys come over to 2, and if you don't want to be in there and you want to go see James, that's fine too. Okay.
Or if you just want to work on stuff with other students and don't want to keep hearing us, go to 3.
Yeah, go to 3. Yeah, that's a good idea.
Oh wait, no, so you're going to do 2.
I'm going to go do. I'm going to do 2. Yeah,
Yeah.
because that's in your head now, right? Like
I know,
that I'm in 2. So, well, I will be in number 2 regardless from now on. And if you don't want to hear us, go to number 3.
Does that mean if I accidentally call you like by the wrong name like more than twice, you just change your name?
Yep, that's it. Yeah, that's happening. Like it's just
Brilliant.
easier than trying to convince you not to.
Cheers, Dave. Right. Okay, I'll be in group 1 in just a second. Right, see you in a bit.
In a minute. And we're back in the room. Can you guys hear me all right? Sweet. Thank you for chat spamming. You guys are the best. Oh, I see how it is. People are going into one, leaving me. I'll remember this. It's fine. Well, I mean, if James isn't coming back, does that mean I've got to do the last bit of the lecture? Can somebody from Troop 1 maybe just pop back there and see if he's still in there? Because I don't think he's back in this chat yet. Just give him a nudge for me. I've got too many tabs open now from jumping between troops and my horrid obsession with having lots of Chrome windows open. I mean, that's pretty smooth. Here we go. The James flavoured up.
Only 4 minutes.
Only
4 minutes over. That's not
Only
too
4
bad.
minutes, yeah.
Only 4. Okay. The next couple of bits are really quite quick anyway, so I'm going to rattle through them. I'll get my screen shared and start.
Okay.
Right, so we're going to look at a few things with strings, and I'm just going to show you some basics. This is not really particularly difficult. What I think I'll do is we'll combine the breakout session for these two, and I'll give you something. The task will be essentially to combine. It makes sense that way, rather than keep going through the context switching of one to the other. Okay, so I'm going to make a new file just to demonstrate this stuff. I'll call it stirstuff.py. So strings, the first thing is, what are they? Well, they're a sequence of individual characters, and that's really important. In Python, before Python 3, so earlier versions of Python, a string was a series of bytes, essentially. That is no longer the case. So in Python now, you can actually have Unicode characters and stuff in there. So, you know, just bear that in mind. You might think, well, that doesn't really make any difference. But if you've done anything in cybersecurity and needed to create byte strings before, strings of actual bytes, then be careful that Python strings don't bite you, as they definitely do to me. And you might have heard Dan getting very, very distressed over his experiences with changing to Python 3 for exactly that purpose. Dan loves a buffer overflow. It's definitely his thing, and he uses Python to generate payloads. Quite a common thing to do, but it can really troll you. So what I mean by that is, if you're in any other sort of version of Python previously, or many of these sort of more classic languages, you have a string and it contains these things. They are just bytes. In here, I can also include Unicode characters. So if I sort of went what's the 8 enter No, that's what do I want? Control X8, enter. There we go. I don't use this very often, so this is to insert Unicode characters in Emacs. So Control X8 and enter. Easy to remember. Don't know why I forgot. Octopus in. There's an octopus. Okay. I'm not going to bother putting all the shebang stuff in here or even doing chmod. I'll show you a different way. For now, just type Python and then the name of the thing I want to run. So in this case, it's stir stuff, and we get a Python, an octopus. A Unicode Python, that would have been a good idea. Try enter. No. Okay. But we've got face with a cowboy hat. There we go. We'll use that one instead. So you can see it works with these kind of characters, and that's partly why the byte string stuff doesn't work in the way you'd expect, because it's not actually just using ASCII characters. So this is just forewarning for much later. If ever you sort of doing this stuff, there is a thing called byte strings which work like the old Python strings. For now, strings are just a sequence of characters. Okay, that's what we're going to refer to them as, whether they're bytes, ASCII, or whatever. It doesn't really matter. We can put them in. The things I wanted to show you, because you've already seen this and you've seen we can go over loops. What I wanted to show you are things like if we want to put two strings together, something we call concatenation. Okay. Okay. The plus works with two strings. That's not a problem at all. It puts the two things together. Very easy. Okay. Makes sense. The other thing that we quite often want to do is to join multiple strings. So let's say, for example, we've got a whole sequence of things. So sequence. So we put square brackets around, which we'll do more of later. It joins them together, and you notice it joins them together with this space because that's what I put at the start. So this looks like odd syntax, but what this means is that strings actually have this as a function attached to them. Okay, you'll see more of that as we go along. So if I wanted to split them with, separate them with a slash, I can do, or I could put, things in between, not a problem. Okay, so this join is kind of handy. The other good thing is you'll notice, like in some places, you think, oh, I want this, I want spaces between them, but not a space at the start or the end. This is one of the easiest ways to do that. All right, so that's join. I'm also going to show you split. So sometimes you have a string, this is a really common one, you've got a string that contains something that has multiple components, and we want to split them out because we need to look at each individual one. So I might say A equals, this is a sentence with some text in it. I'll now print A dot split on space. Okay, so A is the string, dot split means that's a function I'm calling that belongs to A. Again, notice here the function that belongs to this string. So A dot split, and the data I'm giving it is that I want it to split on this. So whenever it sees that space, it's going to split. What you get is this is a sentence with some text in it. So you get all of these broken down parts. How would we use that stuff? Well, let's say I put that into something called parts. Okay. I could print parts and get the same output there. What I can also do individual one. No problem. Okay. So we can work on them, we can do stuff to it, whatever we need to do. I can also do uppercase and lowercase. So split with bonus upper and lower. I actually always forget whether it's two upper or upper because I've used too many languages now. So I'll show you how I remind myself. So I can have a string, which is just a string, and I can then go dir like this to see what that thing can do. Right, so ignore the ones with the underscores, they're the sort of special variables, but you can see there's split, there's join, doing L-just and R-just justification. What I want is the uppercase and lowercase, and if you look down to T, there's no U for upper, so it can't be that, so it must be where is it? Why? Oh, sorry.
Broken?
No, it's off the screen. I hadn't noticed.
Right.
Where's it gone? I thought for a second
Told
Python
yourself.
3.8 to just take it. So there, it's upper, not to upper. So that's what I was looking for. So I dot upper. Just run that now. And there we go. This is a sentence with some text. So it's doing both things. We can do that, and we can also do, if we wanted to, lowercase. So now if we run it twice, and if you look, this at the start, this here is capital, there it's lowercase, but actually it's in sentence case on here, so it's actually got a capital T, but one of them's uppercase, one of them's lowercase in all of the places. Okay, so that's the split, which turns them into sequences. It's very handy. Done concatenation, we've done iteration over them, upper and lower. There was something else I was just thinking I wanted to do. Oh, strip, that was the other one. Sometimes you will have, like you saw earlier, make a menu and you type something in and you check to see what people have typed. So let's say that the user input like this has been typed in, and what they've typed in is quit, and they put a space at the start and the end because, well, they're a user, and that's the kind of stuff that happens. Okay, you have to be able to deal with them doing stuff like this. If user input is equal to quit, quitting else print unknown command, because it's only got one command at the moment. When we run this, you'll see it says unknown command. Okay, we've still got all their other bits of demonstration code. I'm leaving them in there because I'm going to give you a link to this later as a sort of like a quick reference. Clearly, quit with spaces around is not the same as this quit. So what we would do is we would go if this dot strip, and that will strip off any starting or ending white space. Okay, so spaces, carriage returns, that kind of stuff. And now it says it's quitting. Great, but users might also do stuff like this. Still unknown command. So what I would do is I would strip it, and I would add on that I want it to be lowercase, and now it quits. Okay, so you can see I've stripped it and I've made it lowercase. Really handy stuff. That's all the string stuff that I wanted to do. So there you go. So we've got concatenation, join, split, and strip. Some of the most useful things you can do. We haven't yet had a call to use it, but there's also things like find, so you can actually like check where something appears inside of the string. But yeah, as you need those, they're very easy to look up. The one thing I do want to do now, though, is I want to show you how to use things from the command line. So arguments that come in from the user. Okay, so I'm going to call this one argstuff.py. There's a lot of documentation on this, so I'm just running through it quite quickly, but it is essentially the same as the stuff you'll find in, no, not interacting with the network. That comes later. Interacting with the user. Okay, so there's an explanation of how arg works in here as well. So yeah, you've got plenty of sort of longer documentation to look through, and you can also look it up very easily. But what we can do is a quick demo. So here I am going to use the shebang. And I'm going to import, remember this is importing functionality from somewhere else, so I'm going to import the standard set of things in sys. And this gives us access to something called sys.argv. Now, sys.argv will contain all of the things you put on the command line. So the first thing I'm going to do is I'm going to print out the 0th one, okay? So the thing in position 0. This is going to be a sequence for everything we put in there. So let me run this. So chmod u plus x arg stuff, run arg stuff, excuse me, like that. And it just comes back with the same name, okay? Why is that? Well, the first one in the list is always the name of the thing that you run. Okay, so if that was called something else, it would be, called that. You can make this is not something you have to do, but I'm just to demonstrate how that works. ln is something we can use to make links. So this doesn't really have it's not like links on Windows, they work differently. Here it's almost like an alias for the file name. So ln arg stuff y2 just run me. Okay, so now I've got something called run me, and when I run it, it comes up with run me. So whatever it was called, and if you look at ls-l, this run me, it looks like it's something separate. It's the same code. Okay, so that's a symlink to the same thing. Okay, so we can do that. That's great, but it's not really the most useful thing. What is useful is when we start looking at the ones that come afterwards. All right, so now if I use run me and put some stuff on the end, sorry. Reading my own history. You know what? Sometimes using the history is actually slower. I should just do it myself. Okay, it says list index out of range. All right. Why is that? Well, because I'm asking for the second thing along. Remember, it's always 0 for the first one, and then we move along. So I'm asking for the second one along, which means I should actually put something in, otherwise it doesn't exist. Okay, so it just prints out whatever I type afterwards. Now, this is very handy. Okay, the example in the notes just says hello to whoever's there, but you could easily in here use that to tell it a command. So I could say, argv is equal to launch print launching nukes, else print making tea. Okay, so arg stuff, making tea, but if you know that you can type launch, it launches nuke. So you can actually run things with command line parameters. It's also quite good then, because you've probably seen in many places, you run something and then you put a file name on the end. Okay, so we could do arg stuff and then give it star.py, which will put in all of the things that go there. So let's go back to where we were just printing out the first item. And look, that star.py has become ad.py. So maybe we try the first item, the second item, and the third item. Now it prints out 3 Python things, because star.py matches all of those things. So it matches add.py, argstuff.py, counter.py, and stirstuff.py. We can do a lot of useful things with this, and one of the things that you'll do as part of this project in the port scanner shortly is you'll use this so that you can set a target. A good example of this is if we did something like ping. So ping just checks that we've got connectivity to something by sending a message and it coming back, so it's a special protocol. We might ping bbc.co.uk and we get data back, and that bbc.co.uk is an argument that goes in. Okay, there is some more information on this, particularly how to make it not crash when you don't give the right number of arguments, because that's obviously a common problem, and there's a solution to that. It's very, very easy in the notes. I'm not going to go into it now because I just wanted to introduce you to it and make you aware of it. And that's the demo part for today. Is there any questions about the stuff that's there?
So one thing that's come up a few times, actually, some people are interested in having worksheets to work through. So they're interested in the idea of having a bunch of these examples that we've made available to them, and for them to work through altogether. I said that we haven't done this on purpose to not create too much overhead for these guys, but there seems to be quite a few people that are interested in more explicit examples of this stuff.
Okay. Well, I'll tell you. So what I've been doing, if you in here, there's always this introduction, and then it gives you a to do and says, right, go through these things. And then in videos of reading, there's usually a bit that says, right, go and read these and do the tasks that are in there. And so, when you go to like, iteration, for loops, you generally have somewhere in here these test your knowledge bits, usually highlighted with things. So I'll come back and edit that one. So, for example, in what was I doing earlier? Interacting with the user. Down here, but check your understanding. Can you write a thing that does this? Would it be better to have those collected up for each week and say, right, these are the like mini tasks that you should be able to do with the actual questions there? I can put them with those links that were in the list. Would that be helpful? So like you can go, right, what should I expect to be able to do by the end of this week? Look at that list, try them out. Would that help?
Yep.
Okay. So that seems fine to me. That's just different presentation and collecting stuff up.
Yeah.
So if that helps, I'll absolutely do that.
Yeah, I mean, we could also give you some specific examples, like of other worksheets that are available. Online as well, like Real Python. We've spoken about it before. RealPython.com. I want to say. I always say either .org or .com, and it's the wrong one. I think it's Python. RealPython.com. Yeah, RealPython.com. So yeah, they have some really good examples of all of this stuff that we're talking about. So there was some talk about whether or not any of that's useful, or what this is useful for. Essentially, anytime that you want to communicate with any of your users with Python, you're going to need to be able to put a lot of these strings out to a GUI or something, right? But string comprehension, also a lot of this stuff is used for lists. So being able to do this stuff with strings also means that you'll be able to do it with other types later. So trust us when we say this foundational stuff is good to know.
Oh yeah, absolutely. There's so many times when it's useful to or not useful, but like a core thing, and you do it on the way to everything else. So it's not going to solve your big problems. It's the small pieces that you use to put together for those bigger problems, right? So these things are like your core tools.
Yeah. I've never seen codewars.com. I'm going to go and look at it now because that could be cool. There's one other question that came up as well, James, that maybe you could help with. We were talking about recursive functions as well, and I said, like, they're not generally the best thing to use for just, your run-of-the-mill problem. But then we got to thinking, well, all right, cool, there's some edge cases, but what are the edge cases? And I can't think of one right now. I've been working out.
There are loads of places where recursion is actually the most expressive way to put something, right? So in terms of efficiency, it's not really an issue. You can do anything you can do with recursion, you could do without recursion, right? It doesn't matter what it is. I don't think I've ever seen anything you can't do without. It's just so much clearer to do something with recursion. So I'll give you a quick example. Tell you what, if we're okay to sort of skip this breakout, what we'll do is we'll call this the break. We'll take 5 minutes, right? Because we get to the 3 o'clock thing. We'll take 5 minutes, and in those 5 minutes, I will put in some. I will do now an example of some recursive stuff for the people that are interested, just as a sort of like bit of a thought for the future sort of thing. And then at 1:45, I'll do the run through of the project, so how to get started. So that's recorded and done, and that'll be it. So. Should we practice code from the lecture? Yes, you can practice code from the lecture.
Please do.
That seems sensible. Then anyone that wants to take a break, you can take a break. This is just a sort of answering an interest question along the way, and I promised we would have at least a couple of breaks today. So let's take 5 minutes now, and then at 1:45.
There's an interesting thing that Glenn's put in the chat as well. Can we get some hashtags of random tidbits and subject matter that we can cover or that we have covered when you upload the stuff to Owler? So
For the videos.
Yeah.
Yeah, not a bad idea. I'll have to remember to write them down as I go through the video. So remember, which can take a few minutes. So like say 1:45, if we get back around 1:45, it'll give me enough time to do this. Stanley, yes.
Yeah.
I'm going to demand that you use MATLAB now.
Yeah, everyone should. Why not? I mean, no. I mean, it's heavy duty stuff. If you want to use it, use it. Okay. I mean, that's fine.
Asking the last task. So the last bit I'm going to show you is how to get started on this week's project. In fact, this project will be a couple of weeks. So we're going to make a port scanner.
We just need to take the 3 minutes to answer this recursion question because it's interesting. Yes. So take
it's. I'm going to do that now.
Put away chat.
Break time. Right.
Yeah. If you guys want a break, go for a break. We're just going to answer this question on recursion. That's it. See you at 1:45.
I was thinking, what should I do as a good example to start with? It's not going to melt anyone's brain. I haven't got time to draw any fractals.
I know. That's the real answer to what do we use recursion for? Fractal calculations. But
do a quick binary search. That shouldn't be too difficult.
No, right. That should be all right.
So binary search, if we've got a list of things, so let's say we've got a list of numbers and we want to check to see if another value is in there. So what I'm going to do really quickly is I'm going to generate a set of numbers and I'm going to run through this really quite quick. So just bear with me. So I'm going to make a list of numbers, and again, don't necessarily worry about what this looks like. So I'll call it values, and it's going to be equal to, well, start with the empty for I in range 100. So we start off with 4. Values append. So I'm making a list here of numbers. I'm going to take the last number that was in there plus okay. There you go. So what we've got is a sorted list. It's always in order and never out of order, but the gaps between them can be quite large. And this could be, a very large list as well. Okay, so there we go. That's 10,000 values sorted in order, but we have between 0 and 100 difference between each one. So if we wanted to know whether a given number was in there, it's actually quite difficult. If we wanted to go through and say, let's say we were looking for 1,781, right? We could go through and do linear search where we say for I in values, if I is equal to target print found, and that's it. We go through and check each one. So it doesn't find it. Let's go for a smaller gap between the values so that we're much more likely to get it. So 0 and 3. What have I done there? So I'm going to tag myself out there. Right. We go through and it found it. Okay, in fact, it was in there twice that time. We're not in there at all this time, and once that time. So we go through and we find it. The trouble is, as that gets bigger and bigger, it takes us longer and longer to hunt through. So if I just make a count which is equal to 0, do this. Took 1,161 iterations to go through. Okay. And if I don't find it, it's going to go through the entire 10,000 values. So what we might want to do is something called a binary search. And a binary search uses the fact that you've got the start and the end. If you're looking for something in a book, you're looking for a particular page number, you wouldn't go, well, it's not 1, it's not 2, it's not 3. If you knew it was 500, you'd look and see, well, is that about halfway through, or is it not? So what we might do is we might make a function that can search for these things and see if we can get this working quickly without going too long over the time. So
I was going to say we've only got like 13 minutes left of the lesson.
So. Let's just give it a quick go.
Go for it.
Call it L for the list. Target, start, end. Actually, we don't even need to do that with Python. We'll just go for the target. So we'll find the halfway through point. So we'll say the midpoint is equal to the length of the target divided by 2, and we definitely want it to be an integer. And say if mid is equal to target, print found. And I'm going to do something horrible, but you'll see why in a minute. Count equals 0. Horrible count. So every time this function's called, it will add 1 to it. So if the mid is equal to the target, that's fine. Print found. Actually, we should also do a quick check at the start. If the length of the list is less than 1, we're going to just end because we haven't found it.
Yeah, you're absolutely right. Found should be between quotes because we want it to print out.
Yeah,
you're absolutely right.
Thank you. Otherwise, we're going to check, say, if L mid, if we're too low, it's less than the target, then we need to just search in the higher part. So what we would do is we would just run bins on L from the midpoint plus 1 up to the end. Otherwise, we're going to run it on the other side. L from 0 up to the midpoint minus 1. Okay, and I think what we do is just take bins, and we want to look through values for the target that we've set, which is 1781. We should either find it or not find it. L values, where was it? List, I forgot the targets, and the target's the same. And not length of target, length of L. Okay, so it comes up with found, not a problem, but let's see how long it takes, right? So that's good. Double count. Why did I decide to do this? So it goes, it goes through 13. I don't know why I'm not getting the count outside afterwards. Count tries, doesn't matter. But you can see here it goes through 12-ish goes to find that value. And the reason is it's dividing up the array. So that as a recursive method where it calls itself is actually a lot easier to implement than it would be if we did it the other way around. Okay, so that took 5 minutes longer than I wanted, and it's definitely not pretty, and hopefully it hasn't made everyone do what people usually do when they look at recursion for the first time and decide never ever to use it again, because it is actually quite useful. And there's a good example. You could do it without, but it would be much uglier. Right.
It would take much longer as well, especially for much larger data sets.
Well, I mean, you could do the binary search even without recursion. It's just look nice.
Yeah.
Okay. So moving on quickly, because I do want to go through the port scanner. So the port scanner, there's a whole bunch of stuff that's here as explanation, which I'm going to talk through, but read it, right? Because I've put in a lot of stuff here to talk you through why we're doing this and why certain things happen. A port scanner, for those that haven't seen one before, is something that we use to see what ports are open on a host or range of hosts. Okay, so I'm going to just do Nmap, which is the one we're going to use here, and I'm going to run it like this. So this is just saying it's going to be what type and what timing and everything else. So this will run fairly quickly if we just do it on its own. So I'm going to do www.coventry.ac.uk. If you want to know what the options for these things are, man Nmap is really useful. So show you that, gives you all the stuff you might want in here. So definitions for stuff, lots of example uses, and then all of these different options. So you see lots and lots of options. You can find Nmap cheat sheets very easily. And here you see, it says
help
we've got
flag is good too.
the help flag is good too. So, but you can see we've got, I don't know why it does that. We've got a bunch of stuff here that's open. So 80.443, 80.80, and 8.443. So it has a go at telling you what they are. And that's a port scanner. Really, really useful, right? So finding what ports are open, that tells me that, well, I expect, unencrypted HTTP traffic here, then encrypted traffic there. Then we've got these proxy and this alt thing. The alt thing here, the 8.443, is actually going to be it's to do with the load balancing thing. So there's a bunch of stuff going on, and it tells information about it. Okay, it also tells you the addresses. What we're going to do is we're going to build our own port scanner, because unfortunately Nmap only knows about things that currently exist. As new things happen, we don't necessarily get the choice of using Nmap, or at least out of the box with it, particularly if we want any sort of high levels of interaction. So what I've done is I've given you, and there's documentation for Docker as well on there, is there is a target machine. And what we've done is we've done this as a Docker container. So you can copy and paste this straight into here. And this will create, okay, I've already got it running. Where? Let me just move it. What is it? There we go. Container, right? Again, documentation on how to delete and remove the stuff. Okay, there we go. So I thought I'd done this already, just so you'd see what it looks like when you first run it. So here we go, copy, paste. And what it will do is it will realize that you don't have a copy of this. So it will automatically download and run that container from Docker Hub. Okay, so that doesn't take too long. This is like a tiny little virtual machine, but it's not really a full VM. It's very light, very small by comparison. So this is going to be probably a couple of hundred meg, because he's actually running sort of a few different things inside. You can even get ones that smaller, but I didn't bother finessing this. And it runs on your system. It uses your system's resources, but it will have its own IP address. It can have its own ports open. By default, they go onto the range of addresses in the 172.17.0. something, and 2 would be the first one. So when this is finished downloading and it runs, that's the address I'd expect to see it on. So it's like there's a new machine on my network, except only this machine can see it, and it doesn't really need a lot of extra hardware. It even runs inside this VM. So there you go. And here's our target. It's called Wider, and you'll work out why as you go through the challenges and you try the project. But if we look at it with Nmap 172.17.0.2, we can see that it's got some stuff open, some services, but we can't really see anything particularly unusual. But there is actually a service running on it that is part of some malware. and we want to be able to scan that. We don't have a scanner that can easily detect that malware. So we could use, Nmap and give it a broader range of ports, for example, but it wouldn't know what this was. All right. Okay. If you've downloaded the Harbour Master scanner as a starting point, the make file can also be used to run this as well. So if you look, there's a make target. So let's do that bit now. Let's get the repository. Here's the stuff, and you should fork this and then download. So I'm just going to go to the one that I've already got. So here's what you've got. There's stuff in the source, and this is what you're going to be working on. So not Harbour Master answer, because you won't have that one. That's mine. But the Harbour Master file that's there is what you're going to use. You also get access to some documentation. So if we do make docs, activate the thing. Always remember to. Why does it fail? Wait, undone my Vemv. Ah, no, I haven't activated the right one. Sorry. Now make docs. Okay, so if you look inside the documents directory, which you should know from previously, we've got this HTML directory, and if we do Firefox, Harbour Master or HSockets, that's the one that's most useful. This is functionality that you're given. Okay, so test port is a function that you will be able to use to test a given port. Well, I'm telling you this in advance because when you look at the source code, check out Harbour Master source, harbourmaster.py, which is the one you're using, there is from HSockets import test port. So this is the code that you're working with. This is the starting point. As you can see, it's not particularly long, but it's making use of that function. So when you see that function, test port, like here, target and P. So P is a number that we put in a loop. That's what it's doing. And the location, so what host, what port number is there. Okay. What does it do? Well, if you have a look through, it does the classic if name is equal to main. It sets the target to be this. It's fixed at the moment, but you could change that. It goes through a range of ports. At the moment, it goes through 1 to 100, and it uses some coloured stuff. So it sets the message to be equal to closed at the moment, and then it tests the port. And if it's not none, then it says that the port is open. Okay. If the result is greater than 0, it means it receives some data, and so it displays that data. Okay, it adds that onto the message. We see it in action very quickly. Do it in here. Slightly too big. So we'll run Harbour Master. Master.py. Oh, sorry. I'm trying to run a HTML file because I'm trying to be too quick. Source. Oh my goodness. Completion goes wrong. And there we go. So you can see it runs through and it tells you these are closed. This one is open, and it got some data. So actually, it's what we call banner grabbing now. So it actually grab this banner. It tells you what version of the SSH server is on it. It goes through, it goes through, it goes through. It sees that 80 is open but didn't respond, which if you've ever tried playing with a web server using command line, you'll know they don't say anything to you until you ask. So that makes sense, and off it goes. So you can see that this does the scan. You can actually do other things with it. So if we wanted to, we can get it to actually ask for information. So if we did sort of web scan, this actually uses that same function, and this is checked in for you. You can have a look at how it works. It uses this poke, which is what you use to poke in some information. So essentially, it chucks in to anything that's open. It tries a little bit of text and sees what happens. So you can see here that this actually does have some, some response if it's there. And these are the kind of functionality bits you get. Your job is firstly to read through and have a look at the source code that's there, which is this. This is what's happening. The most of the code you have here is just about coloring things. Okay, so colored foreground is green, foreground is red there, foreground is yellow here, and so on. The actual messages and things are just the outputs which get printed at the end. So it's not that complicated. And if you wanted to, you could simplify by taking some of the colors out, get yourself familiar with what's there and build up. So what are you going to do? Your job port scan. So your job, there's the examples, is this. So modify the given port scanner so that it scans for a new piece of malware. Okay, so this is called WIDER, and that's the name of the container that you're using. So that's the target. So we're expecting that to have this malware. And what you want to do is you want to find out, is the port open? Well, firstly, WIDER runs on one of these, but it's random. We don't know which one each time. So you need to check those ports, not just 0 to 100. And also, when you connect, if it's the correct port, if it's actually running that malware service and not just some other thing on there, when it's connected, it will send back this string of things. Okay, so if we're going to do this with Nmap, like just as a standard tool, we do Nmap 172.17.0.2, and we could give it a range of ports. In fact, I can never remember. There we go, cheat sheet. Range of IPs, no, it's a sub, no, port selection. Range of ports, most common. Okay. Can we just put more than one on -P? Let's try. I think we can. Hoping. We have to do something like this. Oh, actually, do you know what? Let's just do a range of ports. We'll do 3,700 to 3,700, 37,800. So. And we can see on this one that it's open, but it doesn't know what it is. Okay, so 37306 is open. It's definitely one of the right ports, 37306, but we don't know whether it's returning this bit of data. If anyone's ever used something called Netcat before, that'd be useful for finding that out. So let's try it. Netcat 172.17.0.2, and we give it the port 37306, and we get back some data, and it matches what we expected. Okay, so there are some questions in here. Can you guess what the ports are for? Can you work that out? Can you work out what that data actually is? We know that's what WIDER sends back, but can you work out what it is? This is the core of what you're doing. I would suggest for this week you try just working on those first parts, and then I'll lead you through next week a little bit further, because we're gonna stick with this for a couple of weeks. So don't worry if you don't get all done this week. Try out the stuff, do the reading that's pointed out, try the challenges which I'll put up. We talked about that list. I'll put some of those up. In the meantime, do we have any questions about what's there?
There was one question about H-sockets.
Yeah.
What are H-sockets?
H-socket is what I call the thing that I made to make this easy. Okay, if you want to see what's in it, you by all means have a look. But it's really, I wanted to be able to say, right, we're gonna use loops and we're gonna do some stringy stuff, but I want to do something that's to do with cybersecurity and hacking. So you can look at what's in H-sockets, and it's here. But I wouldn't necessarily recommend it unless you really want to get into some fairly detailed stuff around sockets. Okay, so there's all kinds of stuff going on here that just to make this work and be fairly bulletproof, so that on the outside, when you're not in there, you can literally just go, just test that port for me, and it gives you a sensible response. In reality, it's actually quite tricky to do port scanning because some things, don't stay open for long. Some things will stay open until you put some data in. Sometimes you try to connect and there's no rejection of the connection, so it's like not even a half open, but it just times out. And I've done it so that for the kind of stuff we're doing with this, you don't need to think about any of those things. So this H sockets is essentially Harbour Master sockets. Okay, it's called Harbour Master because the Harbour Master scans ports. Tish.
Yeah, that's pretty much all of the questions that we've got. Everyone's like, thank you so much. They understand a lot more now this week, so
Brilliant.
they're feeling a lot happier, and there's a lot of stuff. James is running late, so
I am.
he needs to dash. But
Pedro, no, we're not going to be doing threading in this module at the moment. There's it's just a little bit too advanced for what's there. Yeah. Right, I'm going to go. If you have any more questions, then please post them. Adam, are you running away now, or are you hanging around?
No, I'm going to hang about. So just in case there's any last minute questions. But if you need anything from us, guys, you know where we are. Basically.
Right. Take care, and I'll speak to you all very soon.
Ciao for now.
Bye.
You're welcome, guys. Honestly, that's what we're here for. Take care. If you've got any questions, you know where we are.
Is there a fixed target for the port scanner?
There will be. So we're going to provide you with a virtual machine that has some ports that you can try this stuff out on. So there will be. All right.
Okay. Thanks.
Also, is this going to be uploaded on Ola, like this session?
Yes, yeah, the video session will be. I don't know how long it's going to take James to edit the video and stuff, but it will be for sure. All right.
Oh, thank you very much. Have a great day.
And you, buddy. Anybody else? What's the email address that you can send your code to be checked? I would send it to James specifically, only because I'm in the process of getting a staff account, so I might miss your email in the email changes. I'm dreaming of getting a staff account soon. We'll see if it happens before the end of the year. But I would send it to James directly if you want to get your code checked, or you can just message me if you want to get your code checked. Just message me in Teams. It's fine. Send me screenshots. Send me code. It's fine. This is where I get exploited. This is where you guys hack me.
Can we do it in something that isn't Python?
Absolutely, yeah. The point of this is to get you guys doing Python, right? So don't get me wrong, feel free to go away, explore other languages, but when we're talking about the assessments, definitely try and make them Python. I'll have a chat with James about it, just in case there are other languages that he would accept. But yeah, if you genuinely want to use a different language because you can't stand Python for whatever reason, then there's no reason why you can't do all of these exercises in another language. Personally, every time I learn a new language, I'm using I'm doing exactly the same stuff that we're doing here, just in that other language. So you can't use the same principles here, just learning a new syntax. It's up to you. But I would say do Python. Do the Python.
So would it be safe to say that when we submit the code, we should do it in Python and not another language?
Absolutely, yeah. And I'll talk to James about it and see if there are any other languages that he'll accept. But when you're handing in stuff, definitely do it in Python. Okay. For now, until we hear otherwise.
Cool.
Anybody else have any questions? Feel free to unmute yourself or say stuff in chat. I don't mind. You don't have to stick around anymore. That's it. We're done. If you use Kali. Yeah, of course. Yeah. Go do shenanigans. See if you can smash all of the port scanner shenanigans before next week. Honestly, Carlos, if you want to use Kali, I cannot guarantee what issues that there are going to be, right? That is the nature of the beast. We provided a VM on purpose so that we can control at least some of the stuff that you're likely to encounter, the problems that you're likely to encounter. And then also, if you do likely encounter them, many of you will encounter them, if that makes sense. So yeah, that's kind of why we provide a VM in the first place. If you use Kali, like, it depends on what version that you're using. It depends on like what stuff you've already pre-installed. The biggest issue that I can foresee is that, you know, Python 2 and Python 3 come in pre-installed in Kali. You might find that some of the commands don't work. But generally speaking, you know, because we're doing Python 3 stuff and we are doing Python 3 coding, if you do everything the way that we're showing you and you're running it with Python 3, you should have zero problems. That's kind of the point of a programming language. It has to be versatile and work on different platforms. But yeah, like, the answer to your question could be everything, could be nothing. I have no idea what the text is that you're talking about, James. The 117 people will see this message business. The reason that you're probably seeing it though is that due to GDPR regulations, because these sessions are recorded, all sorts of stuff like that, we have to be very careful that you are well informed that messages can be seen by other people, that you are kind of on display, and that things are being recorded. Does that make sense? So we have to be very clear that you understand that that is happening, and then it's up to you almost to engage in any way with, you know, it's up to you how much you engage with these recorded sessions. But that's also why we have the other sessions that aren't recorded, so that you know, if you don't want to be recorded, you can just keep your questions back and either ask us outside of the sessions or in the not recorded sessions, if that makes sense. Mohammed, you guys are going to be assessed on two things. We did cover it in the videos. Have a look at the videos and go back through it. You'll see exactly what you're going to be assessed on, and it will probably answer a lot more of your questions there.
Is there a due date for the port scanner?
So I don't know what the was it. Didn't James say it was the last week of October? He didn't say specifically what what day it would be yet. I think he needs to have a look, but I think he said
I think he said 2 weeks.
Really?
Yeah.
Okay. It might have been the brute force thing that because he wanted that handed in at the end of October, didn't he? I think that's the way around it is. So 2 weeks for the port scanner stuff, the brute forcer is after, and that needs to be handed in at the end of October.
And where would it
That's
be
the way
uploaded to?
What's that? Sorry?
Where would it be uploaded to?
This will be on your own fork. So, you know, James was talking about forking the repo for yourself. This is mostly, the port scanner stuff is mostly for you, right? It's just
the same as transcoder, isn't it, really?
Yeah. It's all about practicing your stuff, and just we're making it about you. You've got to have a repository of code that you have done that you can feel comfortable with, that's got all of your own notes in it. Do you know what I mean? That you don't have to feel assessed on. Ideally, we'd like to do it just so that you guys just had a repository of stuff that was just all yours. It'd be better if you weren't assessed on stuff, but you know, you can't give a degree to somebody without assessing something, right? So this is why we do the assessments the way we do. So we give you the minimum that we can while still giving you a qualification. That's the idea. I'm with you on this one, James. I don't like any of these warnings and stuff. I think there's no clear guidelines as yet as to what is the best way to inform you guys. I mean, like, I'm sitting here saying this, and nothing that I'm saying is really that much of a shock to you, right? You all understand that you're being recorded, that common sense dictates that other people will be able to see this, that it will turn up in the recordings, you know. So there's a certain line that nobody's entirely sure of, where how much is too much, like, informed consent, if that makes sense. You know, we do these things ultimately for you guys. So if you ask a question, everybody gets to see it. sure, but everybody gets benefit from it. Do you see what I mean? Like, there's probably 6 other people who had that same question. So I'm with you on this one. I don't know why they're there, but there's no proper guidelines yet. We're still flying a bit blind. So unfortunately, you might have to put up with it for a bit longer.
Are there going to be any specific libraries, like Python libraries, that we're going to be taught, or?
Yeah, there's a few that will always turn up, right? They do just specifically, they always do. But nothing. We won't go through the libraries. We won't go through the library code specifically. You'll just see like a lot of I guess common functions that get used in the libraries. So there's no formal teaching on the library specifically, but feel free to go away, read any of the stuff. If you've got any questions about specific libraries, chuck me links, ask me questions. I'm more than happy to talk to you about this stuff. All right.
Cool.
Yeah, like I say, we go deep diving into library code. I personally do it, right? I personally go and look inside the libraries, see who wrote the code, how they wrote it. Is it similar to my style? Like, how confusing is it really? Like, are these people really getting published? Those are the kind of questions that go through my mind sometimes. But you know, it's good to understand like what other people do and how they do it and how they're writing their production library code, and if it can inform my development. But yeah, like that we won't specifically do that because that's a bit deep. Do you know what I mean? It's a bit like doing threading. Like if you're doing multiprocessor and multi-threading programming, year 1, stage 1, like you're going to lose a lot of people. So yeah, we need to get you up to you can all code a Python program, and then we can get you hacking with Python. Any more questions? Because I've got a very late lunch and an Amazon parcel that is staring at me.
I'm just here to see who's staying, because I know for a fact that Stephen Rogers is asleep right now.
Oh, really?
Yeah, I'm in a voice chat with him.
And he is like snoring away, is
yeah.
he? Oh, fair enough. Yeah, well, if you guys, I'll hang around for just a couple more minutes.
Sorry.
It's all right. I feel like I want to unmute him and see how bad it is. But yeah, like I'll wait around for just a couple more minutes if you guys just to catch any last minute questions. But if not, you guys know where I am, right? So feel free to ask away at a later date. All right.
No worries. Thank you very much.
You're welcome.
I'm just trying to think of another question at this point.
It's okay. Don't feel pressured. Like there's always later, Adam. You can always message me later. It's fine.
I mean, I'm almost done on my transcoder because I'm the one earlier that said that I did a GUI with it.
Yeah.
I've been using tkinter.
Oh yeah, nice work.
Yeah, and yeah, that is. I've got like the back end and the front end done. I just need to link it up, and that's the slightly more complicated bit.
It can get really dirty as well because you're using tkinter. Do you know what I mean? It's like
yeah.
It's not the cleanest program. It's good for writing tools quickly and getting a fast and dirty GUI going, but it can be there's some tricks to it to master if you want to be a GUI programmer with tkinter. But yeah,
it's a bit of a pain.
Oh, yes.
So the simple stuff is pretty easy, but to start doing everything so it's like resizable and stuff, that can be a bit of a pain sometimes.
Yeah. I might have some material lying around actually, because I've been trying to write some multi-layered, multi-windowed tkinter stuff, which is just blowing my mind hole right now. I would not suggest it in a million years. It's disgusting. Learn to write with a real GUI program, maybe Pygame or something. Yeah, don't do it this way if you're doing multi-layered stuff. But yeah, I might have some resources if you're interested. I'll send them to you.
Yeah, send them over. I was trying to do like a Space Invaders in Python at one point,
Okay.
But then other things in school caught me up with other things, and yeah.
It happens. It happens. Yeah, they're definitely Pygame, that one, if you want to use Python. I
'Cause
originally. Sorry, go on.
There's also Qt5.
Yeah.
But I think that might be like paid for or something. I'm not sure, or licensed in a specific way.
Yeah, you can get student licenses for that. So you
All
guys are
right.
right. I unfortunately have made it to staff territory and now have to pay for mine. So I'm a little bit sore about that. But yeah. And also for the other guys who are interested in using like C# and other languages as well, Qt5 is really good because it lets you integrate a lot of those languages. So not every language, but there's a lot of them. You know, you can code in Ruby and C# and trying to. I had another one in my head and then it's just disappeared. Not the point. Principle. It lets you do loads of graphical user interface stuff.
Because I was using C# for a while because at A level my project was to do like a small game in Unity. So I was using C# for that, but I never got to the point where I could start using GUIs through C#. So I might want to learn that, but I've tried learning C++, and I've got to a basic level, but much further than that, and it's like so in depth, it's crazy.
Yeah, I mean, my first language was C++. Before I came to university, I did a home degree that was all about games design in C++. And boy, that is not an easy language for your first language.
No.
It's especially doing GUI manipulation with C++ because you're doing like stuff in vector space using pointers, and it's well, I mean, I eventually got it and I loved it, but at the same time I'm sort of like, why did I have to do that? Because Python does it so much easier.
But I've found that I just so much prefer like statically typed and pointers and all that stuff. It just makes it, I just get it so much better than all this dynamically typed stuff. It's so much easier to me to go statically typed.
Yeah, for generally speaking, for teaching good computer science, I'm with you on that one 100%. But like I say, we're not really trying to necessarily teach the best computer science. We're making good hackers. Do you know what I mean? So
Yeah, I get you.
it's you know, we'll teach you computer science stuff, but that's sort of secondary to this is how you make a port scanner and this is how we're going to get you hacking stuff.
Yeah.
Do you know what I mean? So that's why we're kind of using Python for, you know, the dynamic language that it is, so that it does a lot of the heavy lifting for us and we don't have to. But yeah, I'm with you on this one. Like, it's also easier. There's a lot of advantages to statically typed languages for testing, for, you know, bug finding and stuff like that as well. So yeah, generally it's what I say about all languages, and we had a little bit of it in the chat earlier. It really is about what language you need to do what job, I think. And statically typed languages are good for large code bases. A really good example of that actually is Dropbox did a talk on, because it's all written in Python, Dropbox. So they did a massive talk on what it takes to run Dropbox, because it's like 100,000 lines of code or something in Python.
Wow.
And because they don't have statically typed languages, testing on that sort of level is just insane. So they've got like what did we learn from it? Like, why would we do it again? Why wouldn't we do it again? Kind of talk that's definitely worth checking out if you want to have a look online.
All right, that's pretty cool.
Right, I am going to go and get some food because I'm starving, and I'm about to be skinnier because, you know, I don't eat now, but it's I'm starving. I'm going to go and get some food. So, but if you guys have got any more like things that you want to chat about, any more questions, you know where I am, right?
Cool.
Bye guys. Bye.
Bye.